Here in session 102, we're going to be looking at equations that contain fractions, which is similar to the proportion that we looked at on the previous lesson. However, here we're going to be dealing with fractions that are contained either on one or both sides of the equation. Here's our problem. 2x over 3 plus x over 6 equals 1. Now, if you remember, in order to be able to add fractions together, we have to have the same denominator. Well, here over at the right-hand side, we don't have a denominator, but we can easily make a fraction out of it by placing 1 in the denominator, and this has not changed the value at all. 1 over 1 is the same thing as 1. So we take a look at our three denominators, 6, 3, and 1, and we determine what is the least common denominator of those three. Well, in this case, the least common denominator is 6. Once you've determined what the least common denominator is, go ahead and multiply both sides of the equation by that least common denominator. So that'll be 6. So we're going to take the left side times 6 and then the right side times 6. Then go ahead and distribute it through. 6 times 2x over 3 is 12x over 3. 6 times x over 6 is going to be 6x over 6. And then on the right hand side, 6 times 1 over 1 is going to be 6 over 6. At this point, we can now simplify. In our 12x over 3, there's a common factor of 3 in both. So 12x over 3 is the same thing as 4x. 6x over 6 is simply the same thing as x. And then over on the right, 6 over 6 is the same thing as 6. Now we can combine together. 4x plus 1x is 5x. And we have 5x equals, on the right-hand side, 6. We now solve it for x by dividing both sides by 5. 5x divided by 5 is x, and 6 divided by 5 is 6 over 5. So our answer here, 6 over 5. And remember, always double check your answers by plugging them back into the original equation and calculating it out to see if your equation holds true. Let's take a look at one more here. 10 over x minus 1 over 3 equals 4. We have two fractions over here. They have to have the same denominator in order for us to subtract them. So let's go ahead and make a fraction out of this over here. So we'll stick a 1 on the bottom. Take a look then at the denominators in each of our monomials here. We have x, 3, and 1. What is the least common denominator of x, 3, and 1? Well, it's going to be x times 3 times 1. Well, x times 3 times 1 is simply 3x. So what we're going to do here is we're going to multiply both sides of the equation by that common denominator of 3x. So on the left-hand side, we're going to have 3x times 10 over x minus 1/3. And then on the right-hand side, we're going to have 3x times 4 over 1. Now let's go ahead and distribute this through. It's the same thing as 3x over 1. 3x over 1 times 10 over x is 30x over x. 3x times minus 1/3 is minus 3x over 3. That takes care of the left side. Then on the right side, we have 3x times 4, which is just simply 12x. Let's go ahead and take each term now and simplify it. 30x over x is the same thing as 30. 3x over 3 is the same thing as x minus x equals 12x. Now we need to get the x's by themselves on one side of the equation. Let's get rid of this minus x over here and move it to the right side. In order to do that, we have to add x to both sides. Well, if we add an x to the left side, that just simply leaves us with a 30 because that positive x and negative x cancel. And by adding the x to the right side, 12x plus x is 13x. Now we still need to get the x by itself. It's being multiplied by 13, so we need to divide both sides by 13. Well, if we divide the right side by 13, we're going to get x because 13x divided by 13 is x. And then on the left side, we're going to have 30 over 13. And that's already in reduced form. 13 is a prime number. So our answer here to this particular problem is 30 over 13. Now, I said to begin with, we need to find a common denominator in order to add or subtract. And once we found that least common denominator, we multiplied both sides by that. But if you look at each of the resulting terms, 30x over x minus 3x over 3 equals 12x, and that would be 12x over 1. We still don't have a common denominator. But what happened was by multiplying both sides by that common denominator, each of our terms now can be reduced to something simpler. That 30x over x reduced to 30, our 3x over 3 reduced to an x that's being subtracted, and then the right side was the 12x. You can see that the result of that is that our fractions are now gone. What we're left with now are just simple terms that have no fraction in it. And that was the goal, was to get rid of the fraction. As a quick review, when an algebraic equation contains fractions, it's often best to find the least common denominator and multiply both sides of the equation by that least common denominator. This will help you simplify the problem. And once it's simplified and you removed your fractions, go ahead and solve the remaining part using normal algebraic strategies. That'll finish up session 102.